In chapter 3, we looked at many different models that can be used when the time series has a trend and we are trying to extrapolate that trend out into the future and finding a forecast for the future time period. Now in this chapter, we're going to look at including the trend. Whenever trend is present, we'll include that too, but our focus is going to be on dealing with seasonal variations that repeat over every cycle. It could be quarterly seasons that are repeated every year, so we'll have 4 seasons that repeat every year, or it could be monthly seasons, that will be 12 seasons repeating every year, or it could be weekly seasons, in which case there will be 52 seasons repeating every year. Or you could have cycle that's not a year long, it could be week long cycle. It will be 7 days a week, so 7 seasons in a week, and that repeats. So you'll have daily sales, 7 days is one cycle, each day is a season. So there could be a variety of ways in which the seasonality data will present itself, and we have to deal with those in an appropriate way. Now typically we're going to see 4 different components on a time series normally. So you'll have trend, then you have seasonal. We already looked at trends, gradual increase over time. Seasonal is the seasonality that is implicit in sales that repeat every cycle of seasons. Then cyclical variation, which is gradual increase or decrease over economic cycles or political cycles that have an impact on sales. And usually we don't have to worry about that because it gets included in trend most of the time. So we do not deal with cyclical variations separately. And of course there is random fluctuations that we cannot help but deal with it somehow, try to minimize the random error. Now we can look at 3 different ways in which these components of a time series can be put together and separated out. So separate out, estimate, and put them back together for forecasting. There is an additive model where we have T plus S. We are assuming that the cyclical variability will get included in trend. So T plus S plus an error. So this is a purely additive model. Or you could have purely multiplicative model where Y is a product of trend, seasonality, and error. In this case, trend would be a kind of a number and seasonality will be an index that you multiply that number with, say 1.2 or 0.8 or something like that, a factor. The times error. Or you could have a mixed additive model where there is a multiplicative nature between trend and seasonality, but the error gets tacked on as an additive quantity. So these are the different ways in which the time series may appear to us, and we're going to look at different models that deal with seasonality. Okay, so there are a couple of basic approaches that we need to understand first. And there is of course this naive approach or random walk approach that we already discussed previously. In the previous cases where there was no seasonality, the actual value of the previous time period is the forecast for the next time period. That's our random walk or naive model. But when seasonality is present, the naive model is not simply the one period before it, but the same season in the previous cycle. So if you have monthly time series, so your naive forecast for January of a given year would be the actual value of not December of the previous year, but January of the previous year. So you go back a full cycle to pick up the actual value and use that as your forecast. That is the naive approach in seasonal variation. So this is what we will use for computing MASE and Thiel's U as the basis upon with which we will compare other models. Because this is the most basic model, most easy to apply and straightforward model, and any other model to be considered, it should do better than this basic model. Then another really basic model is an averaging approach where for the forecast for a given season is the average of actual values of that season in all the previous time periods. So for January, forecast will be all the you take an average of all the Januaries in the previous data points, that the data set that we have. So for February, it'll be an average of all the Februaries and use that. So we are using month is a kind of a placeholder for any period actually. So it could be quarterly. So forecast for a quarter would be the actual value of the same quarter in the previous cycle would be the naive approach, or forecast for a quarter would be the average of that particular quarter from all the previous data in the sample. Okay, so we're going to look at these two examples first, and then we will go into more detailed models.